Hi everyone, welcome to today's lesson. My 3-year-old daughter has something to say to you guys, so let's hear that first before we start.
Let's learn the quadratic function. Are you ready, guys?
Yeah.
Okay, then this is a rainbow. This is coloring. This is a big rainbow.
So she really wanted to say solving quadratic equation by graphing, but that's too long for her, so I kept it short. She wanted to introduce you to today's topic. And we've talked a lot about this already, but there are 3 steps in solving quadratic equations by graphing. First, you need to make sure that your equation is in standard form. Then you need to graph it. Then we're going to find x-intercepts, if there are any. So solutions, roots, x-intercept, they all mean the same thing. So the whole point of this is to solve it by graphing. And you're going to pause the video here and grab your graphing calculators, TI-84s, in order for you to follow the lesson. The very first question is to solve x squared plus 2x equals 3 by graphing. The first step, we're going to make it into standard form, which means we're basically setting the equation equal to 0. So I'm going to subtract 3 on both sides, and I get x squared plus 2x minus 3 is equal to 0. Then we're going to graph it. And yes, we can solve it just by algebraically, but the whole point of this lesson is to use a calculator and graph it. So we turn on our calculators, go to y equals on top, plug in the equation, so x squared plus 2x minus 3. Then we're going to hit graph. And that's a nice parabola we see. And I see that we have 2 x-intercepts right here, one on the left and one on the right. And I'm going to first see, I'm going to teach you how to do this in 2 different ways. I'm going to look at the table values first. So in order to find the x-intercepts, we're going to think about y value being 0. So I'm going to hit second table, which is the same as the graph option. And yes, we can use second calc, but I'm going to teach you that next. So we have all my x values and all my y values by hitting second table. And then I noticed that my x value 1 has a y value of 0, which means my x-intercept is 1. So that's one of the values. Then I know I have to find one more root or one more where y equals 0. And I find that x is negative 3 and y is equal to 0. So yes, it does take some time if your x-intercepts are wide apart or there are bigger numbers or very small numbers. But in this case, it worked out to just use a table. Let's talk about how to use the calc option. We're going to press second calc and go to 0, number 2. 0 means you're going to find zeros of the function, which is the root. It's going to ask you the left bound. Left bound always means your x value is always less first. So it's the smaller x value, then it's going to ask for the right bound. So hit enter, go to the right bound, enter, and then we're going to guess enter. And it actually, the calculator calculates the 0 or the root of the function, and x is equal to negative 3. Then we have to do this one more time because we have 2 x-intercepts. So we're going to do the same thing, second calc, and then left bound is always the lesser x value. We're going to hit enter here and then move with the arrow, go to the top right side of the root, enter, and then enter again. We get 0 is equal to x is equal to 1. So those are the 2 methods in order to use the calculator to find your roots or the solutions. Let's try another one. Solve x squared minus 8x equals negative 16 by graphing. Add 16 on both sides. And then we get x squared minus 8x plus 16 is equal to 0. Pull out your calculators. And if I'm going too fast, just pause the video, rewind it. You could always do that. Feel free to do that. We get x squared minus 8x plus 16. And then we're going to hit graph. I can see that there is an x-intercept, but it might be a repeated root. And I see that from the equation too, but let's do second calc just to make sure. We could also do second table if you want, because that's around 4, right? Your x value 4, where y equals 0. But let's do second calc. Go to 0, enter, left bound. So from that root that you're calculating, hit the left bound, enter. But first you need to find the blinker. So if you don't see the blinker, make sure you play with the arrows and find the blinker by looking at your x and y values. So I move closer to the x-intercept. So I move with my right arrow, go nearby the root, enter, and then go to the right bound of that root, enter, and then enter again. So zeros of the function, we're going to round that to 4 because it's 3.999979. Sometimes it won't give you the most accurate, but because I know that this one has to have a perfect root, 16, I'm going to try that again. So I'm going to go very close to that root, and it gives you closer to 4. So sometimes you'll get right on the dot, sometimes you'll get close to it. But if it helps to go to the second table values, and you can see that to verify that's the root. So 4 is the x value, and then y is equal to 0. Of negative x squared is equal to 2x plus 4 by graphing. So normally we will move the negative x squared by adding x squared on both sides, but I want to try something different. I'm going to graph those two expressions by setting them equal to y. So two separately, just like kind of like systems. So I'm going to put y1 as negative x squared, and then y2 equals 2x plus 4. So I'm separating the two expressions and then setting them equal to one another so that I can see where they intersect, if any. So to check how many roots there are, or if there are any roots, that's how you can check this. So hit graph, and I'm guessing that they won't intersect and there you go. So the both of the graphs need to intersect in order for you to have a root, but they do not intersect. So this one has no solution. And this goes back to our chapter 5 when we talked about systems of linear equations. But now we're dealing with linear and then the quadratic. So this is no solution. So how do we tell the number of solutions of quadratic equation? Very simple. If you have two real solutions, that means you have two x-intercepts. If you have one real solution, that means you have one x-intercept, and vice versa. And then if you have no solution, that means there's no x-intercept. So that's all for today. It's fairly short and to the point. I hope that you enjoyed the lesson and that it made sense. I'll see you in the next video. Bye.